Here we are solving a problem, and the problem is like this: 1 gram of steam at 100 degrees centigrade is mixed with 1 gram of ice at 0 degrees centigrade. What is the resultant temperature is? First thing that I want you to understand is steam is the hot body, ice is the cold body. So according to principle of calorimetry, ice will steam will lose the heat energy and ice will gain the heat energy. So first thing I want to calculate is to convert 1 gram of ice at 0 degrees centigrade. What we need to do? We need to do two things. First, we have to convert 1 gram of ice at 0 degrees centigrade into water. Now there is a change of state. So basing on the definition of latent heat, dq can be written like ml, right? Mass is 1 gram, latent heat is 80 calorie per gram. So how much of the heat required there is 80 calories. So what happened after this step is at 0 degrees centigrade we have 1 gram of water. Say at the best this water can convert into steam, right? For that water to convert into steam, first of all uh, it has to rise its temperature from 0 to 100 degrees centigrade. So what we need to calculate is heat required to raise this 1 gram of water from 0 degree centigrade to 100 degrees centigrade, because it is at 0 and it has to become 100. So there the equilibrium comes, nothing beyond will happen. So how much of the heat required? When there is a change in temperature, amount of the heat required is basing on the definition of specific heat, ms delta T. M is 1 gram of water. Specific heat of water is 1 calorie per gram per Kelvin. Delta T is 0 to 100, that is 100 Kelvin. This Kelvin gets cancelled, this gram and gram will get cancelled. So what is remaining is 100 calories. That implies we can say this 1 gram of ice at 100 degrees centigrade at the best need 1 gram of ice at 0 degree centigrade need heat of how much? dq1 and dq2. dq1 is 80 calories, dq2 is 100 calories, that is 180 calories. So that this ice at 0 degree centigrade is converted into water at 100 degree centigrade. That's one step. Let's go for the next step now. See the next step now carefully. This is all about who gains heat. Who loses heat? This is steam. How much of the steam? 1 gram of the steam. So if total 1 gram of steam at 100 degrees centigrade converts into water, it releases a heat of how much? It releases a heat of dq is equal to ml. Mass is 1 gram of steam, latent heat is 540 calorie per gram, latent heat of water to steam, steam to water. So that is 540 calories. So if you notice carefully, we need a heat of 180 calories, but there can be a maximum release of 540 calories when entire 1 gram of the steam is converted into water. But that 1 gram of that entire that implies, what is the meaning of this? This implies, what we can say implies all steam need not convert into water. Why? We need only 180 calories, where all steam gives 540 calories. That much of the energy is not required. That implies we can calculate mass of steam that is converted into water. When it is happened at what temperature? This conversion always happens at a constant temperature. At 100 degrees centigrade is, I can use a formula dq equal to ml. How much of the heat is required? Only 180 calories. So entire 540 is not taken, only 180 of the heat is given by the hot steam. As much required, that much only it will give. It won't give extra. How much mass we have to calculate? Latent heat is 540 calorie per gram. That implies mass equal to 180 by 540, that is 1 by 3 of gram. So if you notice carefully, out of 1 gram of steam, only 1/3 gram is converted into water, so that it releases a heat of 180 calories. With that 180 calories, all these things will happen. That entire ice is converted into water at 100 degrees centigrade. That's the important point that you need to get. So what is the final thing? What's the final thing? What's the resultant temperature is your question. But I want you to understand what is the final thing is carefully. So finally, what is left out? Finally, ice left out. Is there any ice left out in the problem? Entire ice is converted into water whose temperature is raised to 100 degrees centigrade. There is no ice left out. So ice left out is 0 gram. Water left out. Is there any water? Look at this. Here, this ice converted water, this one, see, ice is converted into water by taking 80 calories, and that water is whose temperature is raised from 0 to 100 degrees centigrade. So water left out is, there is a water here. How much is that? 1 gram. So water left out is, what we can say? Sorry, this pen is not working properly. Just give me a second. Yeah. Water left out is the 1 gram of water here, right? And this 1/3 of the gram, have you seen this? 1/3 of the steam is converted into water. So 1 plus 1 by third of the gram, that is 3 plus 1, that is equal to 4 by 3 times of gram. What is the temperature of this? Here is 100 degrees centigrade. Here also the conversion happened at 100 degrees centigrade. All this conversion happened at 100 degrees centigrade. So that is at 100 degrees centigrade. And is there any steam left out? What is the steam left out? Out of 1 gram of the steam, 1/3 of the steam is converted into water. So 1 minus 1 by 3, that is 2 by 3 of the gram. The steam is also at 100 degrees centigrade. So what is the final temperature is? That's the most important question that we need to address. Water, whatever is remaining at 100 degrees centigrade. Steam, whatever is remaining is at 100 degrees centigrade. That implies what we can say? That implies resultant temperature is 100 degrees centigrade itself. All the steam that is given to you is not burned. Some still is, some steam is still remaining for you, because steam is capable of giving 540 calories, but it need only 180 calories, as I told you. So some steam is left out. Hope you have got this. If you have not got this, I want you to re-look into this video completely once again. After that, if you're still having some doubts, you can post it like a comment. I will help you out. Thank you.